10.2 is on similar figures. A two-dimensional figure is similar to another two-dimensional figure if you can map one figure to the other by a sequence of rotations, reflections, translations, and dilations, which means everything that we have done so far in topic 9 and the beginning of topic 10. So here is a quick example of what we're going to be doing and what's going to show as a similar figure. We have rectangle ABCD, and we're going to translate it 6 units to the left and 1 unit up. We're going to take it and rotate it 90 degrees around the origin, and then we're going to reflect it across the x-axis, across the y-axis, and then we're going to dilate it by a scale factor of 1/2 with a center of 2, -1. And it is still similar to the rectangle of ABCD. As we're looking at triangle ABC and NOP, we want them to be able to describe a sequence of rigid motions followed by a dilation with the center of 0, 0 that's going to map them out. Notice that we're starting with triangle ABC, even though it's bigger, and that A is going to map out to N, and B is going to map out to O, and C is going to map out to P. Okay, you notice that we're going to land with our dilation, so we're going to go ahead and we're going to move triangle ABC first. We're going to translate it 2 units to the right and 4 units up. Once we have that and we've put our dots in place, we know where they're going to land, then we get to go ahead, we redraw our triangle, and then we're going to go ahead and dilate it. You notice that this is really important that you have your little lines that are going to go from your vertex clear out, and as they go out, they're going through P to C prime and through N to A prime, so you can tell that it actually lines up really nicely. Then we're going to go ahead and take, once again, our new versus our old. And our new one is going to be this one right here. So we have 2 compared to our 4. So that means that as we work it through, we're going to have a dilation of 1/2. C, when we have moved it, it is going to be 4, 0. When we go ahead and we multiply that times 1/2, then the 4 is going to become a 2, and 1/2 times 0 is still 0. So that tells us that our new point P is going to go there. So you can see that each one is going to work out. As we read this one, we're also saying that we're describing a sequence of events of rigid motions followed by the dilation. So the first thing that we're going to do is take triangle ABC, which is our smaller one this time, and move it over to DEF, and then we go ahead and we dilate it. So first we're going to go ahead and translate it. As we move it over, we move it 3 units to the left and 1 unit down. And then we're going to go ahead and we're going to map out each one. As we're looking at them, because it is getting larger, then we are going to be multiplying each one. we're going to be multiplying each one times 2. So as we're looking at it, we first go ahead and find our new plot points for A prime, B prime, and C prime. Once we have that, we're going to go ahead and we're going to dilate it. So we're going to multiply each of those points by 2. Notice as you are doing that, that you're from 0, 0, we're still going to be able to make our line through A prime and D, and it's a straight line, through the origin, through B prime, through E, and then from the origin through C prime and F. And you notice each one is doubled. So this is just like what we learned yesterday. Okay, our last question on this topic, or on this part, says, does a given translation followed by a dilation always map a figure to the same image as the one from a dilation followed by a translation? And the answer is no. So here we are given 2 different options. We're starting with the black one, and as we're starting with the black one right here, we're going to look at that, and then they have gone ahead and transitioned it. So they've moved it up to this purple figure, and then they went ahead and dilated it. So we landed here. The other one, we had our black figure, and then we went ahead and dilated it by the same scale factor. So we made it smaller, and then we moved it up, and you notice it landed in a different place. Okay, on this one, at the very bottom, you can see we are going to be moving A, B, C, D to E, F, G, H. The first thing that we're going to do is we're going to reflect it over x equals 1. As we're doing that, that's your red line right there. We're checking to see. So we're going to move each piece over. You should be able to reflect now. We've created our new A prime, B prime, C prime, D prime. And now we're going to go ahead and dilate it. So we first are going to check what's our new and what's our old. Okay, so this one right here is our new over our old, because the new one is the one that we're moving towards. That's the first one. Now that we know that our scale factor is 1/3, now we can multiply each point times 1/3 to find our new points. So I'm going to go ahead and move this quickly for you. And you can go ahead and copy that information down. So we know that each one, as we moved it to 1/3, it's going to give us our new plot points. Okay, on this one, we're going to start with JKLM, which is our small square, and then we're going to move it to PQRS. The first thing that we're going to do is we're going to go ahead and reflect it. We're reflecting it across y equals 1, which is our red dotted line here. And as we do that, you can see that we've made a smaller or the same size square reflected down over. We take those points and we're going to check and see what our scale is going to be. So the first thing that I'm going to do is new over old. The new one, or the one that we want to get to, is this line right here. So it is 1, 2, 3, 4, 5, 6. And our old one was only 2. So this is a scale factor of 3. So each of these that we are multiplying by, once we have found our new prime one, now we're going to go ahead and we're going to multiply those by 3, each one of them. Multiply them by 3. We notice that each one of them works out, and they also stay on our lines. You should be able to draw these lines connecting P through J prime back to the origin, and from the origin to M to S each time, so that you know that they're lined up correctly. Okay, now we have a similar question. Does a reflection followed by a dilation always map to a figure that is the same as a dilation followed by the same reflection? And our answer once again is no. Here we have shown on our black triangle, that is our original, and then we have reflected it, it becomes purple, and then we have dilated it with a scale factor of 1/2, and that becomes our blue one. On the other side, we start with the black one right here. We go ahead and we dilate it down, and then we move it, and you can tell it does not land in the same place. Triangle ADE is the image of ABC after the dilation, and you notice that A still maps out to itself, A prime, and the reason for that is that it was at 0, 0. So even though we have a scale factor of 2, when we multiply that by 2, we're still going to land at 0, 0. Where if we take C, which is at 4, 0, then when we multiply that times 2, we're going to get 8, 0. It is also important that you note that when we are multiplying by 2, then each of our line segments are double in length. So here they're going to show you the line segment of AC is double, or is half the size of A to E. Or from B to C, if we put 2 of those together, then they will equal DE. We want to know if MNO is the same as PQO. First, what we're going to do is we're going to rotate it 180 degrees around the origin, and they actually rotated that in the wrong direction, but because it's 180 degrees, it doesn't matter. So we land with our N down there and then our M. So we have created our new one. Then I want you to notice, once again, we're going to do new over old. So our new one is QP, and you notice that is 3. And then MN is our old one, and that is 2 long. So our scale factor is 3 over 2. Once we have our scale factor, then we're going to go ahead and we're going to multiply each one of those times our scale factor to find our new plot points. So right here, our new plot points for M is P, and the same will be true with N and Q. Okay, we want to know which 2 triangles are similar, and you should notice right away, just shape-wise, that triangle ABC is a right triangle, and so is EFG. So we know those 2 are going to be similar. What we're going to do is we're going to rotate ABC by 90 degrees. Once we have it down by 90 degrees, then we're going to go ahead and we're going to do new over old again. As they're doing the new over old, our new one is 2, and our old one, I'm going right here, that's 2, and then our old one is 4. So our scale factor becomes 1/2. So here we multiply everything by 1/2 and we find our new vertexes or vertices, and we can see that that is going to work and those are going to be similar. Okay, that's it. I hope you've taken really good notes. Go back, rewind if you need to. Make sure that your note sheet is really full of everything that you need to be able to do well on tonight's homework. Thank you.